Hello, everyone, and welcome to the session of the ACS Data Users Conference. This session is Tools and Resources Using ACS Data. My name is Bernie Lenger. I am on the conference committee for the ACS Data Users Group, and I am a senior data analyst at the Center for Court Innovation. And before that, I was at Policy Maps. So I'm really excited for this this session because this really covers some of the most interesting things that I've done for my working life. We'll launch right into it, but let me just tell everybody from the outset, if you have any questions, please ask them through the Q&A box in the Cvent interface. And there's also a chat interface, which is great. You know, at a normal conference in person, it's not really polite to talk while the presentation is going on. But here, I think that's really a great opportunity we have to have conversations about what's being presented. And also there's on Twitter the hashtag ACSConf21, that's ACSCONF21, if you want to keep the conversation going there. So without further ado, we'll get started on our first presentation. So this presentation is with Lisa Berry and Stephen Aviles at Esri. Lisa spent the last 8 years working with ACS data at Esri. She automated the inclusion of ACS data within ArcGIS Living Atlas of the World and worked to promote the use of strong cartography to tell important ACS stories. Stephen is a product engineer with Esri and has been with Esri's Living Atlas of the World team for 6 months. He's worked on policy maps at Esri and is passionate about demography, transportation, and housing-related topics as they relate to GIS. So Lisa and Stephen, take it away.
Awesome, thank you, Bernie. I'm gonna go ahead and share my screen and get us started. Can you guys see the screen? Awesome. All right, so my name is Lisa Berry, like Bernie said. I am a senior product engineer for ArcGIS Living Atlas of the World, and we're on a subset team called the policy mapping team. So we use a lot of ACS data on a day-to-day basis, and we're helping promote its use throughout the GIS platform.
I'm Stephen Aviles. I'm also a product engineer with Esri, and I've been here for 6 months.
The time doesn't matter. What matters is that you're here now, Stephen, right? All right, we're just going to jump right into it today. So when you're choosing a suitable mapping style, something that you've probably heard a million times is that you have to start with a purpose, whether someone has asked you to make a particular map or something along those lines. Some of the questions we like to ask people to consider when they're choosing how to make their map, really you have to think about who's going to be using the map, how they're going to be using it, and what questions might be answered by your map. And while these might seem kind of rudimentary and simple concepts, they really are the core basis for getting you started in your map making process. And so I'm going to actually jump us right into a demo, and I'll be showing this within ArcGIS Online, but these concepts really do span any mapping software. They may use different terms, but essentially the concepts, like I said, will carry through. So here I'm looking at census tracts within Mecklenburg County, North Carolina, in the Charlotte area. And this is a pretty common workflow where we are looking at a particular area and we may be mapping a particular topic. In this case, we're looking at ACS attributes from the newer B28004 table, which is internet connectivity by income range. And so if you were tasked to map the digital divide within your county, here are some concepts that you might consider when following that journey. But again, this will apply to really any concept. So first, if we're tackling digital divide, we might be interested in knowing who does not have internet in our area. And so this data set contains a lot of different breakdown by income range, but we just want to start with rudimentary households that don't have an internet subscription. So this is a total count of households. And so in this case, size is an appropriate mapping style to use when mapping a total because we're showing a quantity. And so size does a really good job of communicating that information. There's a lot of different ways that you can make your size maps easily tell a story and communicate this information well. You can adjust your sizes to be based on maybe the average value. So you notice when I did that, now the areas that are above average are starting to be highlighted. You can play with the size settings a bit more to maybe lower the smaller numbers and raise the higher numbers so that now we're starting to see this kind of interesting, I would almost call it a backwards question mark here in this county of areas where there's more households who don't have internet access. But as we all probably are aware, when we map a total, it can start to look like a total population map because there's going to be more people. So there's going to be more people without internet access. So a common practice is to use a normalized attribute such as a percent. So if we were interested in mapping the percent of households without an internet subscription, when mapping a normalized attribute, color is actually the most appropriate style to be used when mapping a percent or normalized attribute. And what's interesting is here we can still kind of see that backwards question mark going on. And so this actually kind of reinforces what we were already seeing, but this way it's actually normalized by total households. So instead we're really truly seeing the density of households. Some things to keep in mind when you're mapping with color is that there's a lot of different ways that color can be perceived for the end user of your map. So you'll notice this example uses what's called an unclassed method. There's not really any distinct classes, but instead it spreads the colors over the data values so that you'll get a slightly darker color with the higher numbers that you get. You'll notice that the average for the tracts within this county is 13.8. And you'll notice that these two bars by default in ArcGIS Online will actually give you plus or minus 1 standard deviation. So in this case, anything that has the darkest blue or the lightest white are actually statistically significant figures. So this unclassed method is an interesting way to emphasize the statistically significant areas of interest within your map. And so if we were to compare this to a classification method, something to consider when choosing your mapping style is that in this example of a classed method using natural breaks, if I have a data value of say 16, it's going to get a completely different color than 16.5. Those numbers are right next to each other and yet they're getting completely different colors. Whereas 16.5 is going to get the same color as 29, which is a much wider range. So it's just something to, again, to keep in mind when you're choosing your classification method. An unclassed method is something that you might consider. Something else you might consider is a diverging color ramp. I've seen this in a few different examples today, and in ArcGIS technology, this is called the above and below style. Really, it just shows us anything that is above the average will be one color, and anything that's below will be another color. So in this case, anything that's blue is above the average, and anything is red is below the average. We can easily go in and play with the colors here until we're happier with the way that our map looks. And let's say I like this one because it's really emphasizing those areas of this digital divide that the country is facing, especially as we can see in this county, these areas along this freeway system. So here the above and below style is helping us emphasize the tract average. But what we can do is use data.census.gov to extract some national figures in order to anchor this map on something more based. So for example, the national average, if I can get it there, is actually 14. I'm going to go ahead and just type that in. So in this case, we're actually emphasizing anything above or below a national average. But in comparison, actually, if you look at data.census.gov, the county average is 11.7. So you could actually move this down to that number. And so now your map is centered on something more locally based. So what happens when we want to reinforce the two patterns we just saw, color and size? There's actually a way we can do this where essentially we use the same patterns we just saw where they work together in harmony. So if I add back that total figure, so now we have percent being shown in color and total being shown with size, this is now again reinforcing our patterns. And we can go into the settings just like we did before and change some of those configurations like I showed earlier, so that now we're really emphasizing the areas in our map where these areas are in need of internet subscription, which was obviously brought to light very much during 2020. So that was kind of our rule of thumb when mapping a single topic, a single attribute, such as households without internet. But what happens when we want to compare two different things? First, I'll start with comparing two total figures. So let's say we want to compare households without an internet subscription with households that do have an internet subscription. I'm going to scroll through this nice long list. The ACS has done us a favor by giving us lots of attributes to choose from. And so now we're mapping two totals. One style to consider is simply comparing these two attributes, these two totals, as a ratio. In ArcGIS, this is called compare A to B, but this can be done anywhere by simply dividing these two things. And in this case, you can show them as a ratio of A to B, A as a percent of the total, or A as a percent of B. And this is easy. All this does is change the way it looks in the legend. And so these are just, again, considerations to make as you keep in mind who your audience is. Another style that's actually newer to ArcGIS Online is the dot density style, which actually shows us the density of households in this case by whether or not they have internet. We can make each dot represent a household, so that now the legend, it says 1 dot equals 5 households. Oh, households. And we can adjust how many dots represent this value. So in this case, if I brought it to 1 dot equals 1 household, you can still kind of see that pattern going on, that backwards question mark. But really what's interesting about this style is that it's bringing to light the fact that there are actually quite a few households who do have internet. But this is telling us, again, it's reinforcing that pattern of where they necessarily might not have internet. Another style that you might consider when comparing two things is predominance. And all this is saying is which number of these two points of comparison are larger. Are there more households with internet or without? So this map actually is automatically telling us that most households in this county do have broadband internet. But we can see this little pocket right here, this census tract is one of the only ones where there are more households without. And so this might be interesting from a policy perspective of where to target funds and initiatives. So now we've just compared two different things when comparing totals. Now let's keep in mind that you might also want to compare two normalized attributes. For example, if I want to normalize households without internet whose income is above or below $35,000 a year, for example. So if I choose that one along with, let's see if I can find it in this nice, lovely long list. Oh, I chose the wrong one. Excuse me. Sorry. I'll back that up. So households whose income is 35 or more without versus households that make less than 35,000. So let's compare this spectrum of income, but it's already a normalized attribute. There's also a style, it's traditionally called bivariate mapping. This is another way to show it. Here it's called relationship. And all this is doing is saying, here are two distinct patterns, but one might be happening more strongly than the other. And in some areas, they might both be happening at the same time. And so what's interesting about when we brought these two attributes in is, again, we can see that very distinct backwards question mark. But now we're starting to see some interesting signal about the high and low income communities and whether or not they have internet subscription. And so what's interesting about this one is that The areas in blue actually are full of households who make more than 35,000 but still don't have internet subscription. So this style helps us evolve some of these new patterns we might not have found otherwise. And so I'm going to jump us back to the slides. And just to recap what I said, I'll go through this pretty quickly. If you're mapping a single attribute, a single topic, if you're mapping totals, we recommend using size. If you're mapping a normalized attribute, color is the most appropriate. When mapping color, keep in mind that there's unclassed versus classed, and those each have their own benefits. And if you do use color, consider using a diverging color ramp where you can see patterns that are above or below something meaningful, like a national or county figure, or maybe even a threshold, a goal you're trying to meet for a policy. When mapping two attributes, you can even compare these. If you're mapping a single topic with two attributes, you can map the percentage and the total in order to reinforce those patterns using both color and size. But if you're comparing two different topics completely, there are a few different styles that you can consider, where you do either a ratio, a dot density, or a predominance in order to represent those that information in different ways. And finally, just circling back, the bivariate mapping style, which is when you most likely use when mapping two normalized attributes. And with that, those basic rules of thumbs, I will hand it over to my teammate, Stephen, who will show you some examples of these and where they work well.
Thank you, Lisa. I know we only have a minute or so left, so I will go very quick. Just going over a few web map examples that we have, going over the different styles that Lisa has mentioned. This map uses the above and below style, which is great for when you have a threshold or a conventional number. When we're looking at a 40-hour work week, this works perfectly for this style because we have this threshold of 40, and we can easily see where there's areas that are above this threshold and below, such as in the Great Plains of the US, where we see a lot of red indicating a lot more people are working longer hours, such as maybe farmers, which is probably might be the case. This map uses the color and size where we can quickly see the number of renter households that are severely cost burdened, as well as with the color, we can see the percentages, which kind of give us a more normalized and can focus on our idea of the severe housing cost burden households. We can see that Texas is in this lighter blue, indicating that it is maybe lower in percentage than states such as California or New York or Florida. Jump over to this one real quick. We have a relationship style map that is perfect when you want to relate or compare two percentages. In this case, we're comparing the percentage of renter households that are cost burden as well as the percent of owner households that are cost burden. We can see in red that areas in NorCal and SoCal are in red, indicating both renters and owners are cost burden. In the Central Valley, we can see that it's colored in purple, indicating that renters but not owners are cost burden. Hold on. Okay, all right, I'll just go over one more real quick because I think we're out of time, but this map looks at race in the US by dot density. Dot density is great for humanizing the data. Each dot can represent a number of people. The dot density style in this case is really great for showing more than one category. With polygons, you're usually not able to see different racial categories, but with dot density, you can see that in these areas, you can see more orange and purple, or pink rather, indicating that there's a higher number of Black or African American populations and Hispanic populations that you might not be able to see using a polygon type of mapping style. I think we're out of time, but with that, I will just kind of go over just some quick resources that you can see in our slides, and the links are all here. Thank you.
Thank you so much, Lisa and Stephen. It's so important to consider the nature of your data when deciding how to display it, and these are really great fundamentals. I'd go on about how much I got from this, but there's a lot more to get to. So Just a reminder to everyone, please send us your questions in the CVent Q&A section. We'll get to all of the questions we can after the presentations. So next we have Chase Sawyer, who will be talking about measuring community resilience to COVID-19. Chase is a survey statistician at the US Census Bureau. In this role, Chase serves as the team lead for the Community Resilient Estimates, or CRE. This experimental data product provides an accurate measurement of the capacity of individuals and households to absorb, endure, and recover from the health, social, and economic impacts of a disaster such as a hurricane or a pandemic. He's received various awards for his data visualization work at the Census Bureau, including first place at the most recent Census Visathon. So Chase, go ahead.
Thank you, Bernie. And yeah, I'm very excited to be here today to talk a little bit more about this new experimental data product that the US Census Bureau has put out that really has its backbone based on ACS data. And I think this is a great look at what the Census Bureau can do as it looks at using ACS data and other data products to meet data user needs. So just what I'd like to go over today is quickly define resilience and what we mean by it when we're talking about the community resilience estimates, as well as the reasons why the Census Bureau should look to measure it. I'll talk about what we have right now, and it's our data product from the community resilience estimates and where we're planning to go from here. And so resilience, I feel like it's important to just touch on this real quick because the ideas of resilience and vulnerability are still somewhat debated in the academic space. So what we mean when we're talking about resilience with this data product is that community resilience is the measure of the capacity of individuals and households within a community to cope with the external stresses of the impacts of a disaster. And research shows that resilience can be predicted by individual and household traits. And so now to answer this question about why should the Census Bureau be measuring resilience? And so there are a few measures of social vulnerability and resilience that are out there. The CDC's Social Vulnerability Index is one of the most popular measures in this space. And this, along with other measures, are somewhat restricted in the fact that they have to use publicly available decennial census data or American Community Survey data. And this can lead to some issues that we're seeing that these available measures sometimes lack granularity as well as accuracy. And so at the Census Bureau, we have access to this restricted ACS microdata, and using that data allows us to retain some of the correlation of individual risks. And again, this makes it so the Census Bureau almost has a need to be in the space to look at providing information, since this allows us to, when we're using the restricted microdata, we're allowed to retain some of those correlations among individual risks. And the Census Bureau is very capable in this space and can do so. The Census Bureau is known as the nation's leading provider of quality data, and it makes us well positioned to provide an accurate and timely measure of community resilience. The capacity that the model that these estimates are built upon, we're able to adapt it and incorporate new and relevant data as needed. And the Census Bureau also has a track record of inviting collaboration and working with academics and other federal agencies. And there's really this need for the community resilience estimates that's been reiterated by the COVID-19 pandemic. The Census Bureau has been reached out to by many different groups about accessing data And some of these data are fairly easy to put together, such as if someone wants a measure of poverty or of the percentage of people in an area that may not speak a certain language, that we can really gather that data quickly from the American Community Survey. Some of the custom data requests, though, that we've received at the Census Bureau in regards to like vaccine distribution have looked at trying to break or create tabulations by a number of different characteristics. And so this isn't something that the ACS is able to readily develop and put out because there's disclosure avoidance concern and there's resources and time constraints involved. And so the CRE really tries to meet this goal of providing meaningful information using the vast quantities of Census Bureau data that's available. And so what is the CRE? The CRE, or the Community Resilience Estimates, are modeled estimates of social vulnerability. And so we use data from the American Community Survey, the Populations Estimates Program, as well as the National Health Interviews Survey to create this data. The ACS is used to flag individual risk topics, which I'll talk a little bit more about in a second. We use the population estimates to work through our model, how to allocate different people by their track, age group, race, and ethnicity and sex. And then finally, we incorporated the 2018 National Health Interview Survey because it's the principal source of information of the health of non-institutionalized population in the US. And so these this data was used and combined with the ACS data to go ahead and complete our risk flags. And so as the beginning portion of this model, what we go ahead and do is go through the restricted ACS microdata and look for these various characteristics. We have a list of 11. I'll just go ahead and list out a few, but the risk factors for this model were made to focus on the COVID-19 pandemic. And so there's things like being age 65 plus, not having health insurance, as well as household and track crowding are all information that we gleaned from the ACS. We also went ahead and used 3 health risk flags, with those from NHIS, and those being respiratory disease, heart disease, and diabetes. And so we take this ACS data and use modeling techniques that are currently used at the Census Bureau for the small area income and poverty estimates, as well as the small area health insurance estimates, to model an estimate of the number of individuals and the number of risk factors that they have. And so they've been categorized into 3 groups, and we publish these population estimates for the number and percentage of people with 0 flagged risk factors, 1 to 2 flagged risk factors, and then 3 or more risk factors. And that group that has 3 or more risk factors is what we consider the most vulnerable of the vulnerable, and it represents about 26% of the population of the United States. And so we've started to release this data under the Census Bureau's experimental data guidelines. We released our first set of data in June of 2020 using the most recently available ACS data, which at the time was the 2018 ACS data. We're working now to go ahead and publish a newer iteration of that. The 2019 ACS data is available. We've also been working with a number of different stakeholders to discuss what they'd like to see in the way of risk factors. So some things we're considering are removing the health risk factors, since those seem to be moving and changing in importance over time with regards to COVID-19, as well as the fact that, as we've talked with stakeholders, they're very interested in using this data as part of using the social determinants of health, and we don't want those variables to be part of that if they ended up using that data to try to determine those kind of things. So I wanted to go ahead and take a second to go over a few of the different ways that you can access this data. We have a dashboard that's available through the Census Bureau's COVID Data Hub. The data is available for download, and we're also more than willing to have people reach out to us and talk to them about how to use the data and their questions. And so this is that first way, that this Esri dashboard that we've created as part of the COVID-19 Data Hub. And so you're able to go ahead and view the data that we have available. It's available for all of the counties in the United States, as well as all of the census tracts in the United States. And it's actually very timely in the fact that we use the 1-year ACS data collection. So we have all data available for all counties over the course of 2018, as well as data for every tract in 2018. And so that's something we've definitely been proud of, that we're able to publish at the tract level with a 1-year estimate. Because to the best of my knowledge, other than the decennial census, there's nothing that has that short of a turnaround on 1-year data on the tract level. You're also able to go ahead and explore the different risk categories, those with 0 risk factors, those with 1 to 2, or with 3. And also, as we were shown in the last presentation, one of the things you can do here in this Esri dashboard is look at the predominant risk category throughout each of these counties and tracts. I do like to go ahead and just mention the data is available as a comma separated file on the Census Bureau's website. Usually when we talk about the dashboard, everyone thinks that's the only way to access the data. And so that's a great way for people to start to dive into the data, but it is available on the Census Bureau's website if there's another platform that you'd like to run it through. And as I mentioned, we're always willing to speak to people about how they might use an estimate like this. And we've seen some great success when we've done so. Some of the FEMA regions are using this data as an input in how they look at going and distributing mobile vaccination units for COVID-19 vaccinations. We've also seen the same with Maryland Emergency Management Agency, as well as the City of Austin, who have taken our data and made it available as part of those efforts. And we've also started working with the CDC's Social Vulnerability Index staff. They have some great interest in trying to work together to better understand how these methods might give them a more accurate and timely measure of social vulnerability. And so as I just sum up here, that we do recommend using this tool if you're trying to look at the equitable distribution of resources, as well as gather the most statistically accurate and granular level of vulnerability. The fact that we have access to this ACS microdata, as well as these small area methodologies that have been proven through SAPI and SAHI over the last 30 years, is definitely something, or 20 years, is definitely something that shows the value and the worth of the community resilience estimates. As we're moving forward, we're continuing to look at stakeholder engagement and trying to better understand how other agencies and other groups may benefit from such a set of estimates. We're also very interested in looking at creating additional iterations of the CRE, such as things for, or models for hurricanes, wildfires, as well as COVID relief and recovery. As we've done research on this, something that's very, something that is very telling of whether or not you're resilient to a hurricane is what your home is built out of, or if you live in a mobile home. And that isn't always the case if we're looking at COVID-19 recovery, where that's not as important. But we think that by working with stakeholders and creating additional iterations of the community resilience estimates, we'll be able to help get people the data that they need. We're also looking at doing research into what are the best risk factors, how we might go ahead and deal with some of the nuances in the data, as well as how we might look at weighting different risk factors from each other. So I'm very grateful I had the opportunity to present to you today. I hope that if you have questions or would like to talk some more about the estimates, that we can do so here at the end of the presentation. And you're always welcome to reach out to me via email, and I'm happy to talk with you more. So thank you again for your time and for this opportunity to present.
Thanks so much, Chase. It's a really great tool and clearly very important right now. I'm going to move right along. Next, we have Sarah Bertrand-Delise. Again, let me know if I got that right. Sarah is a data scientist for the Centers for Civic Impact at Johns Hopkins University, where she provides technical assistance to city governments on advanced data analytics projects. Since its launch in March of 2020, Sarah has also served as the lead data scientist behind the Johns Hopkins Coronavirus Resource Center, leading the team's analysis of public health data and creation of data visualizations to help the public understand the global pandemic. Sarah began her career at the European Space Agency, where she collaborated with the calibration team of the XMM Newton telescope. So Sarah, go ahead.
Thank you, Bernie, and thank you everybody for joining this session. I'm here today to speak about a tool that we created some time ago to visualize census data regarding housing. So I'm going to first do a bit of an introduction. The Centers for Civic Impact at JHU is an organization that is helping governments to use data to make informed decisions and improve people's quality of life. We provide technical assistance, and we also do some translation of research so that it's readily available for governments that want to do more informed decisions using data. So why is it important to visualize housing data? If we are speaking about, city residents as our audience, then it's a very useful resource to know the landscape of housing in your city. But really, our target audience is local governments, and what we want to do with this tool, or the aim with this tool, was to do show and tell and show governments the kind of things that you can do using census data, how easily available is this data, how many things you can find out in the data and learn about your city, and also to make a call to action. If you know the landscape of housing, then you know how to do, or you can target better how to do interventions, and also evaluate how these interventions behave with time. So it's a bit of an encouragement for these local governments to use this public data resource. And finally, also for benchmarking. Cities are sometimes often very interested in comparing, like, how I'm doing in this topic compared to this other city that is similar to me. What kind of actions I can incorporate from this other city that work there that can also work in my city. So using census data, since it's homogeneous and standardized for the whole country, it's a great resource for benchmarking. So the tool that I'm going to present is a web application. It was built entirely with Python. The web part is done with Django, and the visualizations with Plotly, which is an interactive library. And we are visualizing housing-related quality of life metrics for all the US places with population over 30,000. So for each place, we are going to display first housing overview. Then there is a page for housing affordability related graphs. And then we also allow to compare places and visualize different metrics. So the landing page is that one, and here you have the URL. It's up and working. It's very simple. You have a bit of a technical note description of the data that we are using is ACS 5-year estimates. and a bit of the definitions that we use. And then you can go on and either select a city or go to cities comparison. If you select a city, you will land in this map here. It's just the population map of the US, basically. Something nice that you can click through, or you can just use the drop downs to find a city in the US. So once you select a city, you will land in this kind of page. You're here in the city housing overview, and you will have just a selection of graphs and tables. All the graphs are interactive, which means that you can basically hover over. You will have tooltips. You will also have some buttons where you can like zoom in, select, and change different attributes of the graph. And then each of the visualizations have a bit of an explainer with links to the glossary. So you will have a bit of context of what exactly you're looking at. So the first thing that we show here is just a table with general data about the city, median age, number of housing units, population, and so on. The next thing is basically a comparison of the household income in the city, the corresponding state, and the average of the US. I'm going to show Baltimore as an example because it's our city, so featuring Baltimore here. As you can see, Baltimore has quite a lower median household income compared to the Maryland state, and even lower than the US. If we keep going down in this page, all of our visualizations are basically timelines, so you can see if there is any time change and any kind of event that happened or any kind of policy that was introduced by a local government. You can check if it has any like visual effect. So tenure type, how many own, how many rent, how many vacant, which in Baltimore, it's a kind of an interesting problem. You can also compare here in the next one to the right, the distribution of home prices, and not only by year, but also benchmarking and comparing that with the corresponding state. So it's interesting here, I'm not sure if you can see, but in Baltimore City in particular, you can see how this distribution is bimodal, and how as time goes by, Baltimore City, it's basically the price of the homes are losing value very quickly, not as for the state of Maryland that is going in the opposite direction. We also show the average home occupancy, which at the time there was no variable in the census as number of people per room. So we started doing that as just the average number of people living in the household divided by the average number of rooms. And you can compare that between own and rent, which is a totally different picture. Also, how much is the rent by number of bedrooms? And the last one is an interesting, especially interesting one, which is comparing again owners against renters. How much is the income, which are the bars at the top right of the image, and then the expenses, which are the lines. And here you can see how expenses for owners are slightly higher actually, but the income is way above what is the average income for renters. And here is, starts one of the issues when comparing affordability for owners and for renters. If you switch to the page of housing affordability, you will find metrics about how is the evolution of house values, monthly rents compared to the household income, and how the rents are like steadily increasing with time while home values might even decrease, and definitely not increasing as fast the incomes. Another interesting metric that we have put together is the number of housing units that are affordable to extremely low income households. This is basically extremely low income households are those that are 30% of the mean household of the city. And being affordable means that you spend less than 30% of your income on households. So basically that's the number of households that are available for these extremely low households among the city, which is quite a low number, way more for owning, obviously, but only basically this is telling us that in the city of Baltimore, only 15% of the homes would be affordable for extremely low income households. And then finally, a breakdown by age. As you may probably know, usually young population is the most affected by housing issues. And we can see that here very clearly. You have the top portion of the graph in bars showing the absolute number of homes, and then in percentage breakdown by age. And this is basically how many renters or how many owners in the city live beyond affordability. That is, they are spending more than 30% of their income on housing. And finally, if you want to compare between cities, we have different ways of comparing them. You can select by all the cities in a state, by region, by population, by network. This is if they belong to what were cities network, for example, or then pick a random multi-choice selection. I'm showing here an example. I'm picking all the cities by population that are between 500,000 and 1 million inhabitants. And this will show you here what is the change in household income, what is the change in house prices, in monthly rent, and also in population for all this list of cities. Also, how has the rental and housing affordability changed? This is, again, the number of people that live beyond affordability, breakdown by the type of tenure. And also, how are the taxes evolving with time? You can play around with this slider, see the values for the different years. And basically, well, this is a trend like very well known, like the more value your home, probably the more income you have. But then in color, you have the property tax that you're paying. And this is not that well correlated. So we see some cities for where households are, income is not that high, and house value is neither that high, but still they are paying in proportion a way more high property tax. So you can explore around all these pages in the link that I posted above. Our idea for the future is to keep working on that, update data to include the latest ACS survey, include also visualizations at the neighborhood level, so that our targeted audience, which is mainly local governments, can have a better picture of what is going on in the city with more granularity. But the important thing is that we are using this tool to demonstrate local governments that census data is a very powerful resource, that they can easily access it, and we're showing them how to, digest this data a little bit in the form of visualization, so they can go on and start using that to have a bit of a first look at how is the landscape of housing in your city and what kind of things you might be interested in taking action on. We are also using that to benchmark cities across the country, categorize them with what are similar cities that can, take one of initiatives that they are implementing in some of the cities that are working and have similar conditions, housing related, and then suggest these kind of interventions in other cities. So this is basically everything that I had to show. Thank you so much. If you have any tools that you think that it might be useful for local governments, please contact us. If you're interested in visualizing housing data, also contact us. And I hope this was interesting for you all. Thank you so much.
Thank you, Sarah. That really was great work. Really interesting. And so to move to our last presentation for this session, it's from Ajitnarayanam on creating a spatial equity mapping tool for point data. Ajitnarayanan is a data scientist at the Urban Institute, where he works on research to advance equity and inclusion in rural and urban communities. He enjoys building open source data and mapping tools for researchers and advises on tools such as interactive mapping, big data platforms, and data visualization methods to relevant public policy issues. He also co-leads Urban's R users group and mapping users group to encourage the use of R in geospatial analysis for statistical analysis, data visualization, and automation. So go ahead.
Thank you all so much. So I'm going to go ahead and share my screen and begin. And I will say that everyone else's presentations have been great, and hopefully we followed some of their mapping best practices. So let me just play this from the start. So hi everyone, my name is Ajit and I work at the Urban Institute, and I'm here today to talk about our spatial equity tool. For those of you that are unfamiliar, the Urban Institute is a nonprofit social and economic policy research organization, and we do research on a wide variety of topics. I specifically have done a lot of research on equity in cities and how cities are thinking about it, and that was kind of the motivation behind why we wanted to create this tool in the first place. So what we saw was that governments really want to make equitable policy decisions using reliable and representative data. And in fact, about a month ago, President Biden issued an executive order essentially mandating that most federal agencies look at the equity implications of the policy decisions they take. The problem is that measuring representativeness of data is hard, it's time consuming, and it's expensive. And that's because in order to really benchmark data, you need to have some kind of ground truth data to compare against. You need to figure out what that ground truth measure actually is, whether you can measure it, and whether the data out there exists to capture it. And so measuring whether data itself is representative or biased is often the first step in stopping, let's say, biased data before it's used in decision making and before it leads to biased policy decisions. So to kind of help cities in particular with this problem, we created the spatial equity data tool. So the way that the tool works is the tool works at a city or a census place level. And essentially, users can bring their own data sets with latitude and longitude columns. So in essence, it has to be geographic points. They then input it into our spatial equity tool, which does a series of calculations I'll talk a little bit about later. And then it outputs a dashboard. First, it outputs a map with some geographic disparity scores. And then second, it outputs a chart with some demographic disparity scores. And at a high level, these two things essentially tell us which neighborhoods and which demographic groups are over and underrepresented in your particular data set that you've uploaded. Now, that might be hard to wrap your kind of head around, so we're just going to jump right into a live demo and see how the tool works. And this is the landing page for the tool. We tell you a little bit about how it works, and you have two options. You can either first use some of our sample data sets that we've built in with things on with data sets such as bike share stations in Minneapolis or public Wi-Fi hotspots in New York, or you can upload your own data set, which is what we're going to be doing today. So a great place to find municipal and kind of city level data sets is open data portals from each of your respective cities. Now, I live in DC, and DC has a fantastic open data portal. One of the data sets that I found while perusing here is this data set on wireless hotspots from DC government, which is basically all the publicly accessible hotspots and where they're located throughout the city. I'm going to go ahead and download this as a spreadsheet or a CSV file. And I've already looked at this, so I already know that there are two columns in there marked latitude and longitude, and those are the only requirements to feed it right into our tool. So I'm going to go here, and then I'm going to drag and drop that file in. The tool is going to ask us which columns represent latitude and longitude. It's going to try to guess, but if I want to, I can even change that. And for now, I'm just going to click Run Analysis and see what happens. So this basically transmits the data to our servers. We do some of that computational analysis, and this is really where we pull in a lot of ACS data to compare your data against. So specifically at the top, you can see a short summary of our uploaded data set. We see that there are 469 total rows in the data set, or about 469 total public Wi-Fi hotspots in the city of DC, and none of them were filtered out, and we didn't really weight by anything, which you have the capacity to do, and I'll talk a little bit about later. So the first part of this dashboard is this map, which is essentially tells us which neighborhoods are over and underrepresented in the data. So this specifically tells us what the geographic distribution of our data compared with the city's total population. That may be a little difficult to wrap your head around, so the kind of best way to understand it is to just hover over a tract. So let's hover over this dark blue tract in the northeast of DC. We see that that's census tract 111, and it contains 2.56% of the data points, or 2.56% of, in this case, the city's public Wi-Fi hotspots. However, according to the census data we pulled, it only contains 0.8% of the city's total population. So what we do is we just take the difference between those two numbers, or 1.75%, and we say that's kind of the geographic disparity score, right? If we were to believe that public Wi-Fi hotspots should be distributed in accordance with the city's total population, then this particular neighborhood is actually overrepresented. And so you can kind of take a step back and see how downtown areas of DC and kind of this northeast area of DC, where a lot of military and police office buildings are, tend to be overrepresented with public Wi-Fi hotspots. I'd also like to point out one other feature, which is that oftentimes, in this case, what we're comparing equity to and what we're comparing bias against is the total population, right? We're assuming that the distribution of public Wi-Fi hotspots should match the distribution of the city's total population. But you can change that assumption to a couple of other kind of pre-built-in baseline data sets we built into the tool. So let's say, for example, we wanted to compare the geographic distribution of this data compared to the city's population without internet access. Because let's say that you're a policymaker and you really want to ensure that the households who most need internet access and don't have it at home actually have access. So if I changed it, you'll see that the map changes slightly. There's a lot more gray neighborhoods where we could detect no significant difference. But the patterns, at least for the neighborhoods where the public Wi-Fi hotspots are overrepresented, are about the same. A lot of downtown neighborhoods near the National Mall, and this one big neighborhood in the Northeast tends to be overrepresented. We also have a view, so this is essentially the actual disparity score displayed, but we also have a data comparison where you can kind of see your data side by side with the whatever baseline population you selected. So this is a slider, and I can slide it all the way to the right, and I can see exactly the distribution of my data. So this tract, for example, contains 2.5% of my data, and I can move the scrubber over, and now I can see the baseline population. So if I were to hover over that same tract, I can see that that same tract actually only contains 0.58% of the city's population without internet access. So again, these both maps just tell you which neighborhoods are over and underrepresented. But the other, perhaps more important question is, what kinds of people live in these blue neighborhoods and what kinds of people live in these orange neighborhoods? What demographic groups are over and underrepresented in the data? And so that is shown in this chart, which essentially displays the demographic distribution of your data compared with the city's total population. Note that you cannot change the baseline population for this chart. It's always going to compare your data to the city's total population. But what this chart essentially tells us is all these blue groups at the top are pretty overrepresented in the neighborhoods with public Wi-Fi hotspots. So Black residents, extremely low income residents, and households without internet access are actually overrepresented in the neighborhoods where there are a lot of public Wi-Fi hotspots. And conversely, the neighborhoods without a lot of public Wi-Fi hotspots tend to be largely white, tend to be largely educated, with residents with a bachelor's degree or higher, and to some degree have Latinx residents and residents with less than a high school diploma. And again, these are just a couple of demographic groups on the left you can toggle on and off. So if I wanted to just say focus on kind of the racial gap and see whether certain racial groups had over or underrepresentation of public Wi-Fi hotspots, you can see that here. And again, gray means no significant difference. And this is just a way to basically say, at the city level, not at the neighborhood level, what are the demographic groups that are over and underrepresented? So this kind of gives a bird's eye view of the demographic groups that are either left behind or overrepresented. And finally, we also offer users both on the map data and the chart data to download the data as a CSV or download it as an image. So you can drag and drop it, use the data wherever you want, use the pictures wherever you want, etc. There's also some helpful resources at the bottom, such as all our code, which is open source on GitHub, the technical appendix, and a case study we did, which is essentially a blog about how we envision cities using the tool. And I encourage folks to check it out. I'm going to come right back to the PowerPoint and just talk about a couple of other things and caveats to how we see folks using the tool. So we want to be really explicit about what questions this tool can answer. So questions this tool can answer are, first of all, compared to the population distribution in the city, are certain areas or certain demographic groups over or underrepresented? And are these results kind of statistically significant? Now you can also change the baseline population if you don't just want to look at total population, but this is actually, to be clear, the only question the tool can answer. The questions this tool can't answer that you probably immediately have are, why are certain areas and demographic groups over or underrepresented in my data? And that requires kind of your insight as a critical data user to think about data quality issues, to think about historic biases, public policy decisions in the past, all of which might affect the maps and the data you're seeing now. It also can't answer questions about, the quality or accessibility of the services, and whether they're equal across the city, or whether the population distribution or which one of the baseline populations you select is the right measure to compare your data against. In terms of use cases, I'm just going to go over this quickly. We think that folks could use this tool to kind of measure equity and allocation of local infrastructure, investments, service and hazards. So things like park locations, affordable housing, trash collection centers, childcare centers, et cetera. Things that you think should be distributed somewhat evenly across the city and hopefully in accordance with one of the kind of built-in baseline data sets that we have built into the tool. And second, we also think it can be used for kind of measuring under or over reporting in resident generated data like 311 data or snowplow request data, which more and more cities are kind of using to allocate city resources to the communities most in need. Those systems often might only be coming from certain neighborhoods or certain demographic groups, and our tool gives cities and other folks a good way to understand the biases in their data. And third, really the only requirement for our tool is that it needs to be from a city in the United States with a population above 50,000, and it needs to have latitude and longitude points. So in theory, any geographic data you have with latitude and longitude points could be uploaded and used into our tool. Our tool has a lot of limitations. I'm not going to go over all of them, but the two things I did want to go over were the first two, which is that first, the tool only works at the tract level for a city. And the second, the tool only has a few kind of specifically curated baseline data sets, which may not really be appropriate for your data. So say, for example, you had a data set on requests for snow removal in the city, like the actual baseline data set you'd probably want to compare your data against is something like average snowfall per tract. And that data set might exist, but might be really hard to find out in the wild. And finally, just to kind of conclude things, our tool measures spatial and demographic representativeness of city level or municipal data sets. It compares your uploaded data to quote unquote ground truth data from ACS population densities or a couple of other baseline populations from the ACS. And we believe it's the first step to kind of operationalizing equity measures, making it easy to compare equity, not just across different data sets or across policy domains, but also across cities and across time. And finally, we also think this is a good first step in terms of democratizing data analysis tools for city leaders. The ACS makes it really simple to kind of impute demographic data where there previously was none. So in our example, the public Wi-Fi hotspot data was just a series of points and latitudes and longitudes. We didn't know anything about the demographic composition of those data, but because of the power of ACS data, we're able to impute something about the kinds of people who are being served by those data points. And with that, one last point, our code and tool is all open source. You can find the links here. We're happy to advise and help folks kind of expand our methodology or change whatever you need to make it work for your particular use case. And with that, I will stop there.
Thanks so much, Ajit. That's a really, really cool tool. I'm going to be looking at it when, I'll be honest, I was actually kind of trying to open it up while you're giving the presentation because it was really, really neat looking and useful. So with that, we have a lot of great questions that have already come in. And again, if you have any questions, please put them into the Q&A box at the on the Cvent platform. It would be great if you could also say who the question is for, just because we have a bunch of presentations and it's helped organize it if it's not clear. So I will, I told all the presenters I'd give them a heads up about what questions were coming, but I have not done a good job of that. So it's all going to be on the spot here. I'm going to start off with, for Lisa and Stephen. Let's see. Here's one. With the dot density maps, are the dots randomly placed to represent the data, or are there anonymity considerations in more localized maps?
Yeah, this is a good question. My understanding of the way that the dot density is implemented within ArcGIS Online is that it is randomly placed, and that as you zoom out and in, the dots will actually move. And so they'll never actually represent any single location, because they'll only place dots when using polygon data. So it will be a polygon with randomly placed dots. They're not based off of any geographical XY points or anything like that.
All right, great. Now, question for Chase. Are CRE available as yearly basis? Were ACS 2018 5-year estimates used if you use 2018 NHIS data?
Yeah, that's a great question. And so to answer the time portion of it, one of the actual benefits of the community resilience estimates and the model that we're using is we're using the 1-year ACS data. And so even though we're publishing track level data, that's representative of the 2018 year period. To answer the first part of the question about, are we going to start putting these out every year? That's really the hope. Right now, we're working kind of under that experimental tag, and we're working to kind of refine the variables and move out the 2019 data and then turn around the 2020 data when it's available. But we're definitely not on that production timeline that you get with ACS at this point.
All right, thank you. All right, let's move on. Sarah, and actually, this is a question that I think goes for you and might go for a few of you. But is there any plan to make the housing tool available at the county level?
Yeah, one of the things that we want to do is go down a bit in granularity, because sometimes, data at the city level, it's not very clear. You have, you're averaging many different people in a single dot, so it's not very informative sometimes. So definitely, yes.
And I will also add on to say that some of the most requested features for the tool are it to not just work at the city level, but work at the county, state, and federal level. And that is something we are actively working on and fundraising to make happen.
And that was going to be my next question for you. So let me, here's another question, Ajit, that came in for you. I'm not sure I understand it, but let's see. How can you know what errors are in your data when the rows are removed?
It's a good question. So I think this, and correct me if I'm wrong, whoever asked the question, that if the rows are removed, what that means in the tool is that the tool basically randomly selects a subset of points and tries to figure out what's the most frequently occurring city in your data. So in our case, all our points from DC were from DC, but say we had some points that fell outside of DC, the tool would kind of throw those points out and it would say, we're just keeping the points in DC because the tool only operates at a city level. So if that was your question, I think that's the answer, but I might be misunderstanding.
All right, and okay, going back to Lisa and Stephen. Any suggestions for mapping data on ArcGIS Online with its margins of error?
Yeah, this is a great question, actually. I will just really quickly share my screen just to show you a new resource we actually just released this week. There's a bunch of different resources on learn.arcgis.com. And most recently, we released a bunch of different blogs and resources about margins of error, the coefficient of variation, lots of different mapping techniques, how to include them in your pop-ups, how to show significance between two different estimates. And we have some additional resources coming out down the lines in regards to symbology and other mapping methods. So I can share this link with Bernie to share with you guys, and hopefully this will help you guys out.
thank you. A question for Chase. There are population thresholds for ACS one-year estimates. Do you mean that CRE provide data down to tract level regardless of the size of population?
Yep, yeah, that's the case. So the small area estimates for income and poverty, as well as the small area health insurance estimates, those both are created and use small area modeling methods because we had stakeholders that the ACS data wasn't publishable for all counties on if you hit that 1 year threshold, right? And so using those methods, we're able to go ahead and publish the tract level data on a 1 year time frame as well. So yeah, while ACS has those thresholds and is definitely going to have a lot more data points, CRE doesn't have to abide by them. And so the resilience estimates that we have for all counties and all tracts don't have an income threshold. Or I'm sorry, a population threshold.
All right, thank you. Sarah, and thank you all for these great questions. This is really great to be able to have all of these follow-ups. Sarah, is it possible to break this down along race and ethnicity?
No, not at the moment, but but that might be something very interesting. The idea is to be, continuing adding this to the tool. This is a side project for us, side project. So any suggestions are very welcome, and I think that is a very good one. Thank you.
Thanks. Ajit, is there any reason the spatial equity data tool should not be used at a larger geographic level? You mentioned municipal level, but the questioner doesn't see on the surface why county or state data couldn't be examined.
There is no good reason other than we have not yet built the functionality. That is like one of our most requested features, and so we are working on it. The one trick there is that kind of once you start visualizing stuff as small as tracts and neighborhoods, that can get tricky when you zoom out to say a state or the national level, because there are tons and tons of neighborhoods. And so we're kind of thinking through how to best and most effectively do that. But the methods and kind of the data should stay the same, and there's no good reason you can't do that.
And another question for you: does the point data that gets uploaded to the tool have to represent n equals 1, or can the imported point represent a value greater than 1?
That's a great point, and something I didn't get time to touch on in our tool. So right now in the example I went over, every row equaled kind of 1, n equals 1, but we have the option in our tool to kind of weight data points by a numeric column in the data. So say, for example, you have a column in the public Wi-Fi data that's something like total number of routers at each public Wi-Fi hotspot point. You could weight by the total number of routers so that larger hotspot points with more routers would count for more when doing your equity calculations. And so you can have individual rows count for more or less, or how much ever you want it to when doing the equity calculations.
All right, thank you. Let's see. Do any of you have any questions you want to ask each other? Because there's so much interesting there that I feel like there's so much there could be some cross pollination. I'm just wondering whether you have any questions for each other. We have about 7 minutes or so left, so we can really have a little bit of discussion. And I'll also just mention that there had been that question about margins of error, and tomorrow there's going to be a lightning session on incorporating margins of error into maps that Diana Lavery from Esri and also the ACS Data User Conference Committee will be presenting on. Let's see. Any other questions that have come in?
So Bernie, there was also one question I noticed about accessing ACS data preloaded into ArcGIS Online. Do you mind if I answer that one real quick?
Sure, go ahead.
All right, so I'll just try to show this as quickly as possible. Essentially, the Living Atlas is the easiest way to access this information. You can access the Living Atlas directly within ArcGIS Online, or you can go to livingatlas.arcgis.com. The key phrase that you can search for is current year ACS. And if you do this and filter it by layers, you'll actually access a large amount of ACS tables that are already prepackaged by topic into all these different layers that have tract, county, and state information. And so we actually have quite a few blogs, if you're interested in learning more about this, that describe how to go about accessing this data, what we've done on the back end to get this into ArcGIS Online. I mean, we're really just grabbing it from the API and the boundaries from Tiger. But we have added some interesting things like pre-calculated percentages and whatnot. And so I'll share some of these links in the chat. There's also an FAQ that will answer any and every one of your very detailed questions. But essentially, the Living Atlas is the way to do this. And I'll share some resources that otherwise should help you find these within ArcGIS Online.
All right, well, thank you for that. Once again, thank you all for these really great presentations. You know, I think we just got a message, a chat message from Robert White saying got a pretty good idea of what a dashboard is or should present, and I certainly think so as well. Really, you know, getting the data clearly showing you know, a user who might not be an expert information they need to know. I feel like all these presentations did a great job of showing how to do that. The next session is there's going to be a bunch of roundtable discussions coming up in just a bit at 4 o'clock, and you can just go to the conference website to see what's there, and hope to see you there. Thank you all again.
Thanks, everyone.
Thanks, Bernie.
Thank you.
Thank you.